So today we are gonna see a numerical on beta function where we'll be solving it by the properties of beta function and the properties of gamma function, and there we'll also apply the definition of beta function. So for that, here I have a numerical for you, that is integration from minus pi by 4 to pi by 4 sine theta plus cos theta, the bracket raised to 1 by 3 d theta. Now how to evaluate this integral? So if we want to apply the beta function over here, then first of all let's see what is the definition of beta function. So guys, here this is the definition of beta function, which says, see here point number 4, that sine raised to p theta cos raised to q theta d theta, and limits must be from 0 to pi by 2. Then this is the value by the beta function. So guys, first thing is we have to bring this limit from 0 to pi upon 2 and this power for sine and cos as p and q. So if you'll see here, now in our case limit is from minus pi by 4 to pi by 4. Another thing is, here we have plus sign in between, whereas we want the multiplication sign between sine and cos. So to bring that multiplication sign between sine and cosine, here we'll do some adjustments. So first of all, I'll consider this given integral as I. So I'll say here, let I is equal to integration from minus pi by 4 to pi by 4 sine theta plus cos theta raised to 1 upon 3. Now guys, while doing the adjustment, we do not have any formula for the sine theta plus cos theta raised to 1 by 3. So here we will introduce some terms and then we'll try to find out the answer. So what I'll do is, I will multiply and divide this term with root 2. So by doing it, here we can get a formula. See how? So I'll say I is equal to integration from minus pi upon 4 to pi upon 4, and in the bracket here first of all I'm multiplying with root 2. Now I'll divide, so that will become sine theta into 1 upon root 2 plus cos theta into 1 upon root, and this bracket raised to 1 upon 3 d theta. Now guys, here we know the value of 1 upon root 2 in terms of cosine, so it is cosine pi by 4, and similarly this 1 upon root 2 I can substitute as sine pi by 4. So that will give us the formula of sine a plus b, which will become sine of theta plus pi upon 4, and this root 2 as it is, and this bracket raised to 1 upon 3 d theta, and the integration is from minus pi upon 4 to pi upon 4. Now guys, see here we have eliminated that cos term, and now we'll take the constant outside and we'll use the integration by substitution, or we'll first apply the integration by substitution and in the end we'll take the constant outside and then we can apply the definition of beta function. So here for that I'll say put pi by 4 plus theta equal to t. So here we'll say put pi upon 4 plus theta equal to t. So by doing this, here we will get d theta equals to dt. Now let's see the changes in limits. So for theta we have limits from minus pi upon 4 to pi upon 4. Now let's observe it for t. So when theta is minus pi upon 4, so minus pi upon 4 plus pi upon 4 is 0, so t will be 0. And when theta is pi upon 4, pi by 4 plus pi by 4 is 2 times pi by 4, or I'll say it is pi upon 2. So we got the limit from 0 to pi by 2, which is required for definition of beta function. Now let's substitute everything. So here we'll get I equal to integration from 0 to pi upon 2. We have root 2 raised to 1 upon 3. So here I'll write root 2 raised to 1 upon 3, and in bracket we will get sine raised to 1 upon 3 into t, and d theta is dt. Now guys, Here I can take this constant outside. Now root 2 means 2 raised to half, and raised to 1 by 3 will be 2 raised to 1 by 6. So I'll take 2 raised to 1 upon 6 outside. Integration will get 0 to pi by 2 sine raised to 1 upon 3 t dt. Guys, now we can definitely apply the definition of beta function to evaluate this integration. So come here. So for that we want sine and cos term which are multiplying. Now in our case we do not have cos term, so we'll say that this power q is 0, hence this cos raised to 0 theta is 1, so we just have sine term. So the value of p, that is the power of sine, is 1 upon 3. So p is 1 upon 3 and q is 0. So here we'll say 1 upon 3 plus 1 whole upon 2, and 0 plus 1, that is 1 by 2. So here we will get 2 raised to 1 by 6, then 1 upon 2 beta 1 upon 3 plus 1 whole upon 2 comma 1 by 2. Now let's solve this, let's simplify this. So this will be is equal to 2 raised to 1 upon 6 upon 2, then this will become 3 ones are 3, so 3 plus 1, that is 4 by 3, and this 3 will go down, so that will become 6, so it is 4 by 6. So here I'll say beta of 4 by 6 comma 1 by 2. We can further simplify this by taking this 1 by 6 down, and that will become 1 upon 2 raised to 1 minus 1 by 6. Here I am applying the law of indices formula. This will become beta 2 upon 3 comma 1 by 2. So if we'll solve this, then we will get 1 upon 2 raised to 5 upon 6 into beta 2 upon 3 comma 1 by 2. So guys, here we got the value of integration by using the definition of beta function and the properties of beta and gamma function. So I'm sure that you like this video, and if you want to learn more numericals on beta and gamma function and the other concepts of engineering mathematics, then log into ekira.com today itself, where you will get all the numericals and concept at one place. And if you want to follow me, then you can come to Facebook and Twitter to follow us for the latest updates. Thank you very much.